All right, good morning or afternoon or whatever it is for you today. Today we are going to be talking about summation. When you hear this, you might think, what the heck? I'm not in first grade anymore. I can add two numbers, right? It's pretty easy. 2 plus 2 is 4, and this answer is called the sum. You should know this. If you don't, congratulations. You're about to learn something even fancier. But summation goes a little bit beyond, or a fair bit beyond this, and that's what I'm going to talk about today. So you may have seen some notation like this. This is the capital Greek letter sigma, which is basically equivalent to the English S, so S summation. It makes sense. So something you might see done with this is you'll have something at the bottom, say n equals 1. And then at the top, we're going to have another number. Let's let this be 4. And then in here, we're going to have something involving the letter n. Usually, we could just be a constant, but that doesn't get us much of anywhere. So let's have this be 2n. So what this notation means is that we want to add up a bunch of different terms to get a final result. And this notation after the sigma is basically telling us what we're going to add up. This tells us where we start, and this tells us where we end. So what this is going to be is we're going to start at n equals 1. So if we plug in a value of 1 for n right here, we get 2 times 1 is 2. So that's our first term. And then we're going to increase n by 1. So we're going to plug in a 2 for n. 2 times 2 is 4, so our next term is going to be 4. And what we're going to do between these two terms is we're going to add them together, hence summation. We're going to continue this process, don't confuse that as a plus or minus. We're going to continue this process until we get to whatever our stopping value is. In this case, it is 4. So for n equals 3, 2 times 3 is 6, so we're going to plus 6. And then n equals 4. 2 times 4 is 8. So plus 8, and then we add all of these up, and we get 20. So that's basically the notation for summation. It's not that intimidating once you know what it's asking you to do, but this does have a fair number of applications, and it does get a bit more complex. So let's take a look at something a little bit more intimidating. If I were to tell you to take this sum, you might start looking at me a little bit crazy because I have thrown an infinity symbol up here on the top. And we're not supposed to just lightly deal with infinities, but infinite sums or series are really important in mathematics. And it's basically a whole unit of study. It gets a lot of stuff with this. So what this is telling us to do is to start at 1 and continue on until infinity and add these terms of 1 over n. So what this is going to look like, the first term, 1 over 1 is 1. Second term, 1 over 2 is 1/2, right? Second term, 1 over 3 is 1/3. Fourth term, 1 over 4 is a fourth. And we're going to do this forever. And this is what's known as the harmonic series. And my question for you is, what is this equal to? Does it have a finite value? Over here, when we were dealing with going from one number to another number, it was obviously going to be some easy, constant answer. When we're dealing with infinity, it's a little bit more complex. In the case of the harmonic series, this is what's known as a divergent series, which means that it does not come to a certain sum, that as we approach infinity, we are not approaching any given sum with these numbers. However, this is not the case with all infinite series. That is, if I take the sum from n equals 1 to infinity of 1 over n squared, that's going to be 1 plus a fourth plus a ninth, plus a 16th, and so on and so forth. And this does actually approach a sum. So it is known as a convergent series. Now, finding this sum is a little bit more difficult than something when we're dealing with finite values, but it is still possible, and we have determined the answer for the sum. So figuring out whether or not an infinite series is convergent or divergent is actually a pretty complex process, and there are a lot of different tests that you will learn to address these. And eventually, start getting fancy, and we'll make functions out of these. So I can have an infinite sum that not only includes an n in the function, but also an x. And this is actually going to create a function. And you can use an infinite series like this to create functions that we recognize and use all the time, which is a really cool application. And again, that expands this unit of study really far, and you can do a lot of stuff with it. But that is the general concept of summation. Now, quickly before we go, I'm just going to talk about infinite products. This is related, but it's not something that's going to come up immediately in the study, but I think it's something useful to look at. So another similar notation is the infinite product, and yes, this is a pi. And this could also be finite. So if this is our product here, this capital Greek pi is for product, not to be confused with the constant pi, and it works just like the summation, except instead of adding between the terms, we're going to multiply. So this is 4 times 8 times 16, not 16, 12, and so on and so forth. So that's just the same idea. It's a very similar notation, and I thought it'd be useful to introduce that alongside the sum. So thank you guys so much for watching. If you have any questions or anything else you want to see a lesson on, please feel free to let me know. I hope you enjoyed, and I'll see you in the next video.